Okay, so hello everyone, welcome. Can you hear me? So we are waiting 1 minute, then we'll start. Okay, we will start now. So hope all are you well, and I hope already all of you already get that all of recorded class, and also get the all of practice code. So basically, today's session we discuss about that change detection analysis using Google Earth Engine, as well as how we can easily identify hyperparameter optimization value for different machine learning algorithm. We'll discuss about that. Okay, so let me share my screen. And after completing the 3 hours live training, we talk about that problem solving class. Okay, can you see my screen? Is it visible?
Yes,
Okay,
it's
thank you.
visible.
Okay, thank you. Okay, so let's go straight. Yeah. So, okay, let me sing the topic. Yeah. So today we discuss about that land use, land cover change detection using Google Earth Engine, how we can easily create the change detection. Then we also discuss about that NDVI change detection analysis, and also how we can easily make the classification different types of indices. You can using this process you can create any kinds of classification, any kinds of mapping. Then how we can extract the dense vegetation using thresholding technique, we'll also discuss about that. And also create the class wise land use land cover change detection in one layer, we'll also discuss. And calculate the transition land use land cover area, and also urban development, urban growth monitoring, such as urban spiral mapping or urban expansion mapping. So this type of mapping how we can easily do using Google Earth Engine, we also discuss. And finally, hyperparameter tuning or hyperparameter optimization, how we can easily use and then improving the accuracy of our machine learning model. Okay, so here I already create the land use land cover mapping, and previous class I discussed about that how we can easily use the machine learning and create the land use land cover mapping. So in this case I also use the same process to create this type of land use land cover mapping. And if you check the result, So in this case, basically we take this satellite image for 2013 and 2023. Okay, so we take the two satellite imagery for two time period, two decade, 2013 and 2023, and then further we also try to classify it from satellite imagery mainly vegetation, water body, sand, and build up area for the two time period. So now further we try to calculate change detection and also calculate the transition area. Suppose vegetation to vegetation, vegetation to water body, or build up how much vegetation convert into water body. Okay, how much water body convert into build up, or how much sand land convert into build up. So this type of analysis, and also calculate the transition area, okay, for all of classes. So here we find out this map. So this is the map, mainly it's year of 2023, and if you check the map 2013, so this is the 2013. Okay, so we find out this is the map for 2013. Basically red color indicating about that build up or settlement, and this type of color indicating about the sand land or barren land, blue color indicating about that water body, and then this type of green color indicating about that vegetation area. So we create this type map. So this is the map for in year of 2013, and this is the map year of 2023. Okay, so now we just create the change detection between 2 year 2013 to 2023. How much vegetation decreasing, or how much build up increasing, or how much water body loss, how much vegetation loss. So this type of things we try to calculate between the two map in year of 2013 to 2023, and also calculate all of transition area. Transition mainly water to water, water to vegetation, water to build up, water to barren land. Same also for vegetation to build up, vegetation to water body, vegetation to barren land. So we try to explain all of details step by step. I hope you can easily get the idea. And when you apply the change detection, we need the 2 decade land use land cover mapping. So in this case, I already create this type of map. So now we try to create the change detection step by step and discuss about. And before that, anyone any question? Simply ask. Yeah, any question, please. Okay, I hope there is no question. Yeah. Okay, so let's continue. Okay, so first of all, mainly change detection. We can perform the change detection two types. One is the single class change detection, another is the multiple class change detection. Single class change detection, mainly in this case, we are just talk only for the single class. Suppose I want to focus only for the build up. Okay, and I want to create the build up change detection map between the time period 2013 to 2023, or any single class. Okay, any single class we can use the same process. So one is the single class change detection, another is the multiple class change detection. Okay, so first of all I discuss about the single class change detection, then talk about the multiple class change detection at the same time. So in this case, suppose between this time period 2013 to 2023, I want to check for urban change detection. Okay, I want to create this urban change detection. This process you can also apply for vegetation or water body or any other single class. Just apply the same process. And if you check land use land cover, so basically we simply take this training sample, mainly two satellite imagery. For two time we take the satellite training sample. Mainly first one is for year of 2013, vegetation, water, sand, build up. So this type of training sample we collected from the image in year of 2013, and also vegetation, water, sand, build up. So this type of training sample we collect from image in 2023. Okay, and further we create the model. So in this time we create the model two time. Okay, and then we can check the, okay, I'll just explain the code. You can see the code how we can create this 2 decade land use land cover mapping. So first of all we simply filter our image collection. So just simply take the one image for 2013, another image for 2023. Okay, so you can see data set and data set 1. I put this type of variable. So then I simply take this time period 2013 and also take that 2023 whole year. Further, we try to apply this scaling factor, okay, to get that proper scale value. And further, simply create the median composite for our study area. And then just simply merge all, take the training sample, can the sample and sample one. So first sample, basically this type of vegetation, water, sand. This type of training sample I collected from the image in year of 2013. Okay, and second one, this one is that for 2023. Okay, different image. So we simply already added, you can see two satellite imagery. Just simply open the satellite imagery. So this is the this image, mainly this image for year of 2013, and this image for 2023. So here I simply use the different types of band combination, and further we take the training sample. Okay, and then just simply take that, you can see training, we extract the pixel value. Okay, image and image one. Okay, so basically image 2013, image one is 2023. We extract the pixel value, and further same process, just apply the, take that data set 2 time. Okay, so randomly distributed, okay, for the 2 time, and further we just apply the same process and then create this classification result. So here if you check the result, basically classified and classified one, we take the 2 variable. So basically classified, this variable stored the land use land cover map 2013, and classified one, this variable stored the land use land cover map 2023. And this is the layer, you can see this is the land use land cover, and this is the land use land cover 2023. So this 2 decade land use land cover map we created and stored in this variable classified and classified one. So now I want to work for single class. Suppose in this case I want to work for only for the build up, only for the build up I want to work. So first of all, we just create the single class map. Suppose in this map, if you check it, this map, it show the all of classes, but I want to work only for the single class, only for the build up area I want to work, because I want to create the single class change detection of build up area between the time period 2013 to 2023. So for the region, I need to create the single class map of build up. Suppose I create the single class map of build up 2013 and 2023. Okay, and we already checked these 2 map, basically classified and classified one. These 2 variable stored the land use land cover map 2013 and 2023. Okay, so now I want to create the single class map. So how I can create the single class map? So for that we have to check the value. Okay, value mainly if you check the geometry import, you can see we find out the value 0 for vegetation, we take water 1, then sand 2, and build up 3. If you check it, it's the 3 value, it's the level of build up. Okay, we already know about that. When you set the level, we need to set the value. Okay, so then we simply put the value for 3 indicating about that build up class. And also if you check it, suppose you can see also same, we put this to the, we also put the 3. Okay, 3 mainly indicating about the level. Okay, we already know about that. In the supervised machine learning model, we need to set the pre-categorized data or level data. So in this case, for the build up, I set the level is 3, and I want to create only for the single class of build up. So that's why I need to call the 3 level. Okay, so for this region, you can check the code. So suppose I take a variable build up area 2023. You can put any name as a variable, and then call the classified one, because this classified one, this variable stored the land use land cover map of 2023. Okay, this 2023, this map is stored in this variable, and I need only for the single class, only for the urban class. So that's why I simply put here the equal to 3. 3 is the level of urban or build up. Okay, so now this variable is stored only for the build up information and created only for the build up class. So now further I want to display it. So now we create the binary class. Okay, binary class mainly we find out the build up and non build up. Okay, only for the 2 class. I want to add a layer. So this layer show me the result build up and non build up. So for that, just I call this build up area 2023. I put here the mean and max 0 and 1. Okay, and 0 indicating there is no build up, mainly non build up. and one is represent about that build up, and I want to display the build up as a red color. Okay, as a red color, and I put the layer name 2023. So in this case, if I run the code, it create the another layer, and this layer just show the class of build up and non build up area in year of 2023. So now this type of red color indicating about that build up, and this type of gray color indicating about that non build up. So we create this binary class only for the two class, build up and non build up. Okay, suppose you want to create the map for suppose vegetation, single class of vegetation. So further you have to check mainly what is the level of vegetation. If you check the level of vegetation 0, so just you simply put here the 0 equal to 0, and now it is stored the only for the vegetation class, and I want to create the binary class of vegetation. So for that, simply I want to check suppose vegetation and non-vegetation. Vegetation class I display as a suppose green color, and non-vegetation I want to display the gray color, or any color you can choose. So now run the code. Now it display the only for the vegetation class map, basically vegetation area and non-vegetation area we find out. So now you can see this type of green pixel indicating about that vegetation area only for vegetation, and other gray color indicating about that non-vegetation area. Okay, so same process we can easily create any kinds of single class map using this process. Suppose I want to create the map for water body or sand land. So if you can check what is the sand land value or level, sand land level is 2. So for that, simply put equal to 2, and I want to display the sand land as a suppose yellow color. So now run the code. So now it display the sand land and non sand land class. So we find out that this type of place is the sand land. Again, others gray color indicating about the non sand land. So this is the process. Using this process, we can easily create any single class map. And this type of single class map we can easily export as a GOT file format. Same process, export image to drive, and then we can easily export. So in this case, we try to discuss about the urban change detection. So that's why I need to choose the urban class level. And urban class level mainly build up. This level is for this is 3. So just I keep 3, and then create the urban area as a red color, and I put the layer name urban 2023. So now run the code. So now it create the layer only for the urban class and non-urban, urban and non-urban in year of 2023. And this is the process we can easily create any kinds of single class map. Suppose I create a total 4 class, but in this case I want to work only for the one class, only for the build up or water body or vegetation. Just simply select the level number. Okay, and further I want to calculate the area, mainly how much urban area in available in my map. In this map we find out the two class, urban and non-urban. So I want to calculate how much urban or how much build up area in year of 2023. I want to calculate this value. So this thing we can easily do randomly. We already know about a function ee.image.pixel area. So basically this function calculated the pixel area in square meter. So for that reason we simply take a variable. Suppose I put the variable name is that urban area, and I want to calculate the urban area from this layer. So simply call this variable name, because this variable is stored this map. Simply call, and for connecting simply multiply with this function ee.image.pixel area. Okay, and then further calculate the total pixel area for a specific boundary. We need to use the function reduce region function. We already use lot of time this function for calculating the average value or standard deviation value or minimum value, maximum value, okay, for any specific boundary. So in this case, in this specific boundary, I want to calculate the total pixel of urban, how much area. So for that, just take a variable, suppose r1 2023, okay, and then apply the reducer. I want to calculate the total area, so I put here the ee.reducer.sum and define the geometry. It's my shapefile variable name, and then scale, mainly land set for 30 meter we keep, and max pixel. Basically when you work with the big study area, sometimes we face the problem computation error, then we need to define the max pixel 1e13. Okay, so now further just run the code, then it computed, just simply print this variable, then it computed the total area of urban. We find out in year of 2023. So we find out the result, you can see as a dictionary. So we find out this type of value, very long value, because this unit is the square meter. Okay, further you can easily convert this unit into a square kilometer or hectare. So now how I can convert the unit? For conversion this unit, we just simply take a variable. Suppose I put the variable name is that urban area 2023 square kilometer. You can put any name as a variable, and it's a number. Okay, it's a number. When you define any number, we need to use the e.number function. Okay, and this number is stored in this variable. So just I put the variable, and you can see this number get from classification. Okay, get from classification. So that's why we also need to write here dot get and put the classification. Okay, after that I need to convert into a square kilometer, mainly a square meter to a square kilometer. So for that simply divided 1 is 6, 1 into 10 to the 6. Now it convert as a square kilometer, and further just print this variable, mainly urban area 2023 square kilometer, this variable just print and run the code. It now it show the result in square kilometer unit. So okay, it show the result. You can see 824.99 square kilometer area in R1 in 2023. Find out. Okay, and using this process, any single class area, suppose you want to calculate the vegetation area or barren land area or water body area, any specific classes area you want to calculate, just apply the same process for any land use land cover classification. Okay, please, any question?
So my question is, are we supposed to be applying a threshold, because the the change might also be the reverse. Sometimes a place that was had vegetation might lose the vegetation, and are we supposed to apply a threshold, because sometimes you just want probably the positive change, not the negative change?
Why you apply the threshold?
So sometimes, assuming you want to map water changes, but sometimes the change might be somewhere that had water has lost the water, but sometimes you just want to find those pixels that have gained water, not the ones that have lost water.
So in this case, we already define all of classes. Okay, we are already define all of classes, land use land cover, we already define. Okay, so now it is ready, but I think you talk about that this type of change detection, which I discuss later, using the thresholding. Basically we apply for indices. When you apply the indices and further you want to make the thresholding, then we apply the threshold value, extract the vegetation.
Oh,
Okay, but in this
uh, uh,
case your land use land cover map is ready. We already
oh,
define all of pixel for water, vegetation, sand build up using machine learning. Okay.
Yeah, we already defined that the issue, the question, the reason why I'm asking that is because I once submitted this assignment related to this, and the person told me that these changes you are reporting are like somewhere that had built up but changed to no build up, but they just wanted you to show those that gained. You see the pixels that didn't have build up but now built up instead of just doing the ones that even lost the build up. I don't know if that makes sense.
So basically in this case, we try to create this land use land cover, and further we try to use it. In this case, there is not need to put any kind of thresholding value, because we already make the land use land cover classes. Okay. So now between these classes, we create this map for two time period, 2023 and 2013. So now this is the map for 2013 and this is the map for 2023. Okay. So now between these two map, we find out that change detection. Okay. It can be multiple change detection or single class change detection. Both of things I will try to explain. But other types of change detection, it only based on the indices. Suppose I just use NDVI and further I extract the NDVI value. Suppose 0 greater than 0.4 all of pixel, and then further we just make the change detection using the thresholding value. But in this case, here we already completed the land use land cover classification, and now we just make the change detection between these two decade land use land cover classes, multiple class and also single class. Okay, so let me finish, then you can ask the question again, no problem. Okay, so we find out this type of result. This result we find out that 824.99 square kilometer area in R1 2023. Okay, so now let's do the same things also for this land use land cover map 2013. Okay, this same procedures apply for this land use land cover 2013. So for that same procedures apply. Just take a variable, suppose build up area 2013, and call this classified, because this variable is stored in this map. Okay, we already display this two variable, classified and classified one. This classified, this variable stored the land use land cover map of in 2013. Okay, so here I set equal to 3, equal to 3, because if you check the level of build up, it's the 3. So this value is simply put in here, and further we are just display the binary class build up and non build up area. So now here red color indicating about the build up and gray color indicating about the non build up, and I put it, this layer name is the urban 2013. So now run the code and display the result. So here you can see find out this another map. Basically this is the map in urban 2013, mainly urban and non-urban. This type of red color indicating about that urban area, and this type of gray color indicating about the non-urban area. So if you check these two map, you can see, so you can easily identify urban expansion. So you can see this type of place there is no urban, but we find out the urban in 2023. Suppose in this case I want to create, suppose urban spiral mapping. Okay, suppose this is the urban 2023. So basically 2013, this is the urban map 2013, and this is the urban for 2023. Okay, you can see increasing. So now I want to create the different color. Suppose I want to create this urban 2013 another color, and 2023 provide the another color. So we can easily get the idea. This two urban, this urban area in year of 2013, and this urban area is year of 2023. So we can easily get this idea. Okay, so here you can see 2023 it create this type of road, and 2013 there is no road. Okay, so let's try to read how we can easily create for urban spiral mapping. So for doing these things, it also possible if you want to create the more better map. So for that you need to simply download the geotip file format from here, and then you can easily use the ArcMap or QGIS software. Then you can easily do it. But in this case, we also use the self marks function, and further we also create. Okay, suppose in this case I put here that self marks. Self marks mainly in this case it create the single class, not binary class. Okay, so in this case I just create only for the urban area. Okay, and non-urban area it just remove, it's not need. So just a self marks, use the self marks, and further not need to mention here the binary class, just I remove, and I put the urban area 2023 only for the single class, because when I apply the self marks, then this layer work as a single layer. I want to display it as a red color. Suppose in urban area 2023 I display it as a red color. Same things we also apply for that for in here. So I create the self marks and create the single class of urban in year of 2013. Okay, so let's go try to do it. Just remove it, and I need to define this color urban map in year of 2013. Suppose I need to define it as a uh, suppose yellow color, or any color you can simply choose. So now yellow color represent urban in 2013, and red color represent in urban in 2023. So let's check the result first. So here you can see find out this type of map. Let me zoom. So in this case, you can see we find out this type of yellow color. It's indicating the R1 in year of 2013. And this type of red color, we find out that in urban area in 2023. So basically, urban sprawl is the expansion of cities and towns into the undeveloped or rural areas. Okay, so in this time we find out this type of place is the urban expansion, and we find out that this is the yellow color. It's indicating about the urban in year of 2013, and red color it's indicating about the urban in year of 2023. Not only for that, if you want you can also add the more decade. Suppose you start from 90, then 2000, then 2010 to 2020, then you also get the more better understand how urban expansion year by year or 10 years gap, how much urban is expansion. Okay, annually we can easily get this type of map easily. But in this case I just use only for the two decade 2013 and 2023. So that's why you can get this type of expansion. But when you work with suppose long historical time 1990, then 2000, 2010, 2020, okay, or any specific for take the time period and create this type of land use land cover map, and also create this type of expansion map or urban spiral mapping, then it will be more better. We can easily get, and we can easily get the idea how urban is expanded. Okay, and further, if you want, you can also check the direction urban gradient. So for that, you can easily download this type of data, and you can easily get the lot of tutorial in ArcMap or QGIS how we can easily get the direction, which direction urban change rapidly. We can easily get this type of idea. Okay, so this is the urban sprawl mapping we can easily create, but this is not proper way. But you can simply download this type of layer as a geotip file format, and further use the ArcMap or QGIS software to create the map for your research paper or presentation. Okay, any question in here? Okay, I hope we can get the idea how we can easily create the urban expansion mapping in Google Earth Engine. Just need to use the self marks and then remove the binary class. Take the only for the single class and then represent. You can easily represent from any specific time period. Okay, using this way. Okay, so now further I want to calculate it how much urban area in year of 2013. So same process we also apply. Suppose I just take a variable urban area, and then I call the build up area 2013, multiply this function, then calculate the total area, and also just convert these things into a square kilometer. Just I use the same code, just I simply uncomment and run the code again. Okay, so now run the code. So in this case, if you check the result, so in this case we find out that this is the urban area in year of 2013, 586.44, and this is the urban area in 2023. So simply subtract this value, we find out that almost 238 238.55, yeah, 238.55. So this square kilometer area we find out that urban. So how much urban increased between this time period? We find out that just simply subtract this 238.55. Okay, so after doing this calculation, I want to check newly set up urban area. Suppose in this case, we find out that just simply subtract these two value, we can easily get the result. How much area increased? How much area increased for urban? We find out that 238.55. But where it increased? Where the place newly set up urban area to 238.55. Okay, I want to find out it. Okay, and where there is no changed, basically changed and unchanged between the urban class, and we find out that newly set up urban, how much area? 238.55 square kilometer area. So I want to define in my map, I want to display it, this type of place is the newly set up urban area, and this area is 238.55 square meter. So these things we can easily represent, just simply subtract the two layer. One is that urban area 2000, sorry, build up area 2023 and 2013. Okay, you can see we already create the map, two map we already created. So simply subtract build up urban 2023 subtract with urban 2013, then we can easily find out that 238.55 square kilometer area where newly set up. Okay, so let's go try to do it. Just simply subtract. So for that I just take a variable, suppose urban change map, put here, and call the build up area 2023. It subtract with build up area 2013, basically two layer. This two layer is simply subtract, and further we create this binary class changed and unchanged area. Okay, basically there is no change, show as a gray color, And where this change, it shows the pink color. Pink color mainly it's indicating about that newly set up urban area. And how much area newly set up urban area we already calculated. Simply subtract 284 and 586, we find out the 238 square kilometer area. So now this pink color indicating about the 238.55 square kilometer area, and this is the newly set up urban area. And other, there is no changed, it's totally unchanged area. Gray color, it's unchanged area. So let's check the result. Let me run the code. So here you can see now it find out that pink color. Basically this type of place, there was no urban. Okay, this is the newly set up urban area. And how much area? We already calculated the area. Simply subtract 824 and 586, basically these two value. Then we can easily get this result. Then we can easily get this result. How much area? 238.55. So this type of place, we find out that change area. Basically this type of place, there was no urban in year of 2013, and 2023 newly set up this type of urban area. Okay, so this also you can see this type of place shows a gray color because this place was urban in 2013 and 2023 also urban. So there is no change, totally unchanged area. Okay, so in this case this type of pink color indicating about the unchanged area, and this type of this type of gray color indicating about the unchanged area, and this type of pink color indicating about the changed area. And we find out that how much area? We find out the 238. Okay, urban change area. So these things you can simply export, and further you can also create the map. Okay, so now it one kind of change only for that specific class. But when I do for at the same time, I want to calculate all of change detection result and also calculate the transition area. All of those I want to do at the same time. So I hope you can easily get the idea how we can easily work with that. Okay, anyone any question you can ask me for that single class change detection for urban class. Any question or any contribution you can ask me. Okay, I hope there is no question. Yeah. And further, we also calculate the area. Suppose we already calculate the area. When we subtract the result, we can easily get the result 238. Okay. But if you want, you can also calculate the area, also Google Earth Engine. So for that, simply call the urban change map. Same process. Change area we calculate. So urban change area. Then I simply call that urban change map, this variable, multiply with the function e.image.pixel area. And further, we calculate the total area. Okay, just uncomment and run the code. And in this case, you can say I use at the 100-meter. Sometime we face some problem for calculating the area, because when it across the limit, then it cannot be calculated the area. Okay, so then for the reason I simply increase this scale value, then mainly pixel size value of cell, and then calculate the area. But it's not the proper way to calculating. But Google Earth Engine also some limitation. For when you across the limit, we face this type of problem. If I just put the 30-meter and calculate the area, then it show the error. Mainly it show there are a lot of pixel, so that's why it cannot be calculated. We find out this type of problem. So in this case, we find out this type of result. If you check it, and further we just convert in a square kilometer. So same process, simply call. Suppose just define. Okay, write me the code again. So I take the variable, suppose a square kilometer area, and it's a number. So define e dot number, and further call it. Simply copy this variable, and these things I get from this classification. So simply copy, and it's a string, so that's why I use at the quotation. and paste, and finally divide. 1 is 6 to convert. So just print and run the code. So now you can get the result in square kilometer unit. So we find out the 228, okay, because in this case if I just put the 30 meter and it will be work, then you also get the same result, but in this case I calculate using the 100 meter scale value, so that's why we find out the 228. But our subtraction value, when I subtract, then I find out the 238, but in this case the 228. Okay, so if you just put the proper scale, then you also get the accurate value. In this case we calculate the pixel area, pixel size will increase, so that's why we can find out this type of some low value. Okay, because I increase the pixel size. Okay, so now we talk about the multiple change detection, how we can easily apply. So this change detection mainly single class we already discussed. So using this process, any single class, water body change detection, vegetation change detection, or any class, okay, using the same process. But when we apply the multiple class change detection, then we also need to some step. First of all, we need to create the reclassify. Okay, so when you do for multi-class, then we need to reclassify for land use land cover classes. Suppose here we already create the land use land cover map 2023 and 2013. So these two land use land cover mapping we need to reclassify. Reclassify mainly, how I can reclassify? Reclassify mainly, you can see I set the level 0, then I set the value 1, then 2, then 3, also 0, then 1, then 2 and 3. And when I reclassify, then vegetation 1, I reclassify 0, 1, then water is 2, then 3 and 4. Okay, so just I reclassify value, reclassify the level. So for reclassify this type of level, because further I need to use this type of variable and make the analysis. So for that first step we need to reclassify. And how I can reclassify? For reclassify, suppose I just take a variable before class I simply call and then I call the classified. Okay, classified. So it stored the map 2013. Okay, so just I call this classified because this variable stored the land use land cover map 2013. So just I reclassify. Okay, so how we can reclassify? For reclassify you have to use the remap function and put here the previous value mainly 0, 1, 2, 3. 0 is for water vegetation, 1 is for water, 2 is for sand, 3 is for build up. So this value I want to convert into 1, 2, 3, 4. Okay, when I converted 1, 2, 3, 4, then vegetation is 1, water is 2, sand is 3, build up is 4. So just we simply reclassify using the remap function. Okay, I call the classified because this variable stored the land use land cover map in year of 2013. So just I simply call this map land use land cover map and then apply the remap function, and then I create the list all of my previous value, and then I set the new value which I want to set. I set 0 is 1, 1 is 2, 2 is 3, 3 is 4. Okay, so now this variable before class, this variable stored the land use land cover map. In this map, vegetation is 1, water is 2, sand is 3, build up is 4. Okay, same process we also did for the land use land cover map 2023, same process. So for that, just take the another variable. Suppose I put the variable name is the after class and call the classified 1 because this variable is stored the land use land cover map in year of 2023. So just I remap and then just convert all of value. 0 will be 1, 1 will be 2, 2 will be 3, 3 will be 4, and this variable is stored. Okay, so just we first step is the reclassify 0 to 3 into 1 to 4, both land use land cover classes. Okay, so after reclassify, we just simply check mainly overall changed and unchanged. Okay, overall changed and unchanged we simply check. So basically it's the changed and unchanged area between the time period 2013 to 2023. So for that, simply take a variable. Suppose I put the variable name is the changed and call the after class mainly 2023, subtract with before class 2013. Okay, and further we display the result. Basically this map indicating about the changed and unchanged area between these two time period, overall change, not for specific classes. So further I also show you that for specific classes how we can easily check. So in this case, this layer indicating about the overall changed and unchanged area between the time period 2013 to 2023. So now let's check, run the code. Okay, so now we find out that this type of two class mainly changed and unchanged area. So white color indicating about that unchanged area and red color is the changed area. Okay, so it shows the overall changed and unchanged area between the time period 2013 to 2023. Suppose a total changed area and total unchanged area, but which class changed and which class I got. So this type of things further we'll also discuss and also display the map also. But in this case, it's called the overall changed and unchanged area between the time period 2013 to 2023. Okay, so now we discuss about that how we can easily calculate the specific class changes result and also display. Suppose it's called the transition mainly. Suppose in year of 2013 this place was suppose water, and 2023 this place find out the build up. So water to build up, okay, water class convert into build up in 2023. Suppose this place was barren land, so this type of barren land convert into build up. So barren land convert into build up. So how much barren land convert into build up? How much water body convert into vegetation or convert into build up? So this type of information called as a transition area. So we can easily calculate the transition area in Google Earth Engine and also calculate and make the map, change detection map. So let's go to discuss about that. And for calculating the transition area, we first of all we already make the reclassify. Okay, so this is the main region to make the reclassify, because further I use it and make the calculate the transition area between this 2013 to 2023. Suppose how much vegetation in 2013 convert into build up in year of 2023. So this type of calculation, in this time we also discuss about that. So it called the transition area. So let's go ahead and discuss about that. So for transition, suppose you can see here, I also write some example. Suppose 2013 vegetation, 2023 vegetation, how much area? Suppose I have a vegetation class, so how much vegetation convert into 2023 as a vegetation class, same class. Suppose I have a vegetation 2013, how much vegetation convert into water in year of 2023? I have a vegetation, how much vegetation convert into sand land in year of 2023? How much vegetation convert into build up in 2023? Same process also you can see, water to water, water to vegetation. So first one is 2013, mainly before class, before and then after 2023. Okay, so water to water, then water to vegetation, then water to sand, then water to build up. It means that how much build up, how much water body convert into build up in year of 2023. Same process also you can see, sand to vegetation, sand to water, sand to sand, sand to build up. Mainly how much sand in 2013 convert into build up in year of 2023. So this type of things called as a transition, and we can easily calculate the transition area using Google Earth Engine. Also you can see same process, build up to vegetation, build up to water, build up to sand, and build up to build up, how much area convert. So in this case we try to calculate all of classes. So basically you can see here I mentioned some value 101, 102, 103, 104. So 101 means that vegetation to vegetation, because in this case I already put the value 1 2 3 4, then 1 2 3 4, I already reclassify for this region. So in this case this type of value, suppose 101, 102, 103, 104, what is the meaning about that 101, 102, 103? This one mainly before class mainly 2013, and this 3 is mainly after class is 2023. Okay, so 1 is for vegetation, 1 is vegetation, and 3 for, we find out that sand. So vegetation to sand, how much area convert, vegetation to build up, how much area, so it including about that. So now I need to calculate this type of class 101, 102, 103, 104. Okay, and this one basically first you can see this first value indicating about the before class, and this value indicating about the after class. So this one is for before class, this 2 is for after class, mainly this one is for 2013 and this 2 is for 2023. Okay, so same all of those. So now we try to create this type of value, and it's called the transition. So for creating this type of value we are just use a formula, and this formula is that, so just I take a variable, suppose marched, you can put any name as a variable, and then I call the before class mainly 2013, multiply with 100, add with after class mainly 2023. We already reclassify and stored the before class and after class. Okay, we already make the reclassify in this variable, reclassify before class and after class. So further we simply apply this formula, and then I put the rename transition. Okay, you can put any name, I put the rename as a transition, basically it's one kind of band name, I put the band name transition. So now further if I just print this, simply print and take the result what I can get. So we find out it's one kind of band, mainly it's a transition band it create, and this band you can see its type is the image, and we find out the only one band. And if you check the transition value, this type of value 101 to 404. Okay, so 101 to 404 it indicating about that all of value was this, it means that it including 101, 102, 103, 104, then 201, 202, 203, 204, then 301, 302, 303, 304, and finally 401, 402, 403, 404. And what is the meaning about that? I hope you already know about that. What is the meaning about that 101, 102, 103? So this type of meaning, so basically it depend on your level, set the level. Okay, so it's also set the level. So in this case for in this code I want to set vegetation is the 1, water is the 2, then 3, and it's a 4, build up is the 4. So that's why it means that 101 it means that vegetation to vegetation, 102 means that vegetation to water, 103 means that vegetation to sand, 104 means that vegetation to build up. Okay, same 201, 203, 203, 204, same. Okay, but when you work with for your own, and it also depend on your level. Okay, it's not depend on your level. So we create the transition. this type of transition we create. Okay, 101. So now we try to calculate the pixel number. Suppose how much pixel convert one class to another class. I want to calculate it. So it called the frequency histogram. So we can easily calculate, suppose how much pixel, suppose water to build up. So how much water pixel convert into build up. Suppose sand to vegetation. How much pixel sand convert into vegetation in year of 2023. So this type of information we also calculate from here. So it's further we need to call the frequency histogram. Okay, so basically this ee.reducer.frequency histogram, this frequency histogram calculate the pixel number, how much pixel number convert, okay, from vegetation to water, or build up to sand, build up to vegetation, or vegetation to build up. So this type of things we also created using the frequency histogram. So for that, just we call these things. So just use it. So just call the masked, okay, because it stored all of this band, it stored all of information 1012.404, all of information. So now for the just run the code. So now it calculate the pixel number for each classes, each transition classes.